Hi everyone, we're just going to do a warm-up today and practice using all the rules together again. So our first question, use appropriate rules to find the derivative in simplified factored form. So in A, we're given a quotient of two functions, so it's a quotient rule. So we're going to do our first, second function derivative. So our first function is 7, and our second one we're going to write as 5 minus 2x to the 1/2. Derivative of 7x is 7. Derivative of 5 minus 2x to the 1/2 is a half, times 5 minus 2x to the negative 1/2. And then don't forget there's a chain rule here, so times the inner derivative, which is -2. And then simplify, so that's going to be -1, but you can just write -5 minus 2x to the -1/2. And then we crisscross. So the quotient rule says derivative of the first times the second minus the first times the derivative of the second. So it's minus -1 times 7x, so that's plus 7x, times 5 minus 2x to the -1/2, all over the second squared. So that's the quotient rule. Then we have to put it in simplified factored form, so we want to look at the two chunks on the top and find out the greatest common factor. So I'm comparing 7 and 7x, 7's the common factor, and then the 5 minus 2x to the -1/2, and then divide each green chunk by the greatest common factor. 7 divided by 7 is 1. 5 minus 2x to the 1/2 divided by 5 minus 2x to the -1/2 is just 5 minus 2x. And then plus 7x divided by 7 is x. And then 5 minus 2x to the -1/2 divided by itself is 1. All over the second squared, so that's going to be 5 minus 2x to the 1. And then these ones are the same in the top and the bottom. So I've got my 7. And then if I divide these powers with the same base, I keep the base 5 minus 2x. And then -1/2 minus 1 is -3/2. And then inside the bracket here, these are like terms, so I just get 5 minus x. But then to write it without negative exponents and in radicals, the 7 stays in the numerator, same with the 5 minus x. And then in the denominator, I'd have the bottom means square root, because it's the root number. Square root is with a 2 in the bottom, of 5 minus 2x all cubed, like that. So that would be simplified factored form. Okay, the second one, so we're still doing simplified factored form. This one is a product rule. We have a function of x times another function of x. So again, we're going to do our chart here. So our first function is 2x squared minus x all to the 5th. And our second function is 2x plus 3 to the 1/2. The derivative of the first one is going to be 5 times 2x squared minus x to the 4th times the inner derivative here, which is 4x minus 1. And can't really be simplified. Maybe put the smaller exponent out first, but. And then the derivative of the second is going to be a half times 2x plus 3 to the -1/2. And then times the inner derivative here, which is going to be 2. Here we can simplify. A half times 2 is 1. So the derivative is going to be 2x plus 3 to the -1/2. and then those correspond, and those correspond. So come down here, g prime at x, derivative of the first times the second, so 5 times 4x minus 1 times 2x squared minus x to the fourth times 2x plus 3 to the half, plus, product rule has a plus, the first times the derivative of the second. There's no monomial terms anywhere, so just put our binomial power functions multiplying together there. All right, now we need the greatest common factor. So we've got two fairly big chunks here. So there's no monomial term to compare. There's only 4x minus 1 in the first one. So the 2x squared minus x to the fourth is the lower exponent. And the 2x plus 3 to the negative 1/2 is the smaller exponent. So that's our greatest common factor. We're going to divide each big green chunk by the greatest common factor. So we're going to have the 5 still, the 4x minus 1 still. The 2x squared minus x will can't divide out to 1. And the 2x plus 3 to the half divided by 2x plus 3 to the negative 1/2 is just 2x plus 3. And then plus 2x squared minus x to the power of 1. And the 2x plus 3's divide out. Okay. So I'm going to keep the 2x squared minus x to the fourth here. Move the 2x plus 3 to the bottom and make it the square root of 2x plus 3. And then I'm going to start simplifying inside the brackets here in the square brackets. So I can see I'm going to have to do FOIL. So I can do this. So that's going to give me 8x squared plus 12x minus 2x minus 3 plus 2x squared minus x so 2x squared minus x to the fourth times, so now I distribute the 5, 40x squared plus 60x minus 10x minus 15 plus 2x squared minus x all over the square root of 2x plus 3 g prime at x 2x squared minus x to the fourth times, so I've got a 40x squared plus 2x squared is 42x squared. 60x minus 10x is 50x, minus x is 49x, so plus 49x, minus 15, all over the square root of 2x plus 3. Is there a common factor? 7 is the 49 and 1 are the only things that go into 49. 7 also goes into 42, but not 15. And this would be a yikes complex trinomial, but if you tried 42 times negative 15, you wouldn't be able to find numbers that also added to 49, so that is it then in simplified form. Okay, C. So this is one, I like to think of this one as chain rule first, because it's all to the fourth power. So I'm going to do 4 times x cubed minus 4x over 3x squared plus 7 to the third. And then I'm going to take the derivative of what's inside. So inner derivative is going to require me to make a chart. So my first function is x cubed minus 4x, and the derivative is 3x squared minus 4. and the second function is 3x squared plus 7, and the derivative is 6x. So in the quotient rule, you have derivative of the first times the second. They're both binomials. And then there's minus the first times the derivative of the second. I'm going to put the monomial term first. All over the second, 3x squared plus 7 squared. And now we just have to simplify. So I'm going to rewrite this, that's all to the third, as x cubed minus 4x to the third over 3x squared plus 7 to the third. And then here I've got a FOIL to do in the numerator. So that's going to give me 9x squared plus 21x squared minus 12x squared minus 28 minus 6x to the fourth plus 24x squared over 3x squared plus 7 all squared. So I've got 4 times x cubed minus 4x cubed times, right, so let's collect my x squared terms. Oops. So I've got, oh, this should be 9x to the fourth, my bad. So the x to the fourth terms, I've got 9x to the fourth minus 6x to the fourth, so that's 3x to the fourth. Those are gone. And then my x squared terms, I've got 21 minus 12 plus 24, so plus 33x squared minus 28. And then all over, these are the same. So I'm multiplying powers with the same base, so I'm going to keep the base of 3x squared plus 7 to the power of 5. And there's no 3's in common with the first two, but not the last one. So there it is in simplified factored form. And last one for us to try with the warm-up. Find the slope of the tangent to the curve f at x equals the square root of x plus 1 all over 2x at the point where x is 8. So I don't have to put it in simplified factored form, but I may want to put it in a form that's as easy as possible to sub 8 into. So I'm going to rewrite it first as x plus 1 over 2x all to the exponent of a half. And when I derive it, I'm going to think of it as a chain rule first question. So a half times x plus 1 over 2x to the negative half, and then multiply by the derivative of what's inside the inner derivative, which is going to involve a quotient rule. So the first function is x plus 1, and the derivative is 1. And the second function is 2x, and the derivative is 2. And the quotient rule is derivative of the first times the second minus the first times the derivative of the second all over the second squared. Okay, so an exponent rule says that if you have a fraction, so here's a fraction to a negative exponent, you can flip the base and the exponent becomes positive. So I'm going to use that rule there so that I have a positive exponent. And then my next step, I could apply it to the numerator and denominator separately if I want to. And then I'm going to start cleaning up inside my square brackets. So in the numerator here, I'm going to have 2x minus 2x, that's nice, minus 2 over 4x squared, because that's 2x times 2x. So I just want to make it, again, easy to substitute into. So I may leave this then as the square root of 2x over x plus 1 times 2x minus 2x is negative 2 over 4x squared. And so this is like three things all multiplying together. So it doesn't matter what order you multiply them in to. So a half times negative a half, if you want to think about negative 2 over 4 reducing to negative a half times negative a half is negative a quarter, but I still have that x squared in the bottom, times the square root of 2x over x plus 1. So now I should be able to find f prime at 8. So that's going to be negative 1 over 4 times 8 squared times the square root of 2 times 8 over 8 plus 1. So f prime at 8 is going to be negative 1 over 64 times 4, which is 256, times the square root of 16 over 9. So f prime at 8 is going to be negative 1 over 256 times, so the square root of 16 is 4 and the square root of 9 is 3. So that's going to be negative 4 over 768, but I know top and bottom are divisible by 4. So therefore the slope of the tangent is going to be negative 1 over 192. All right, so that's our warm-up on using all of the different rules together. Thanks, guys.